Okay, let's take a look at number 9 in section 7.1. We're going to evaluate using integration by parts, and here's our integration by parts formula. If we look at the integral we're integrating, seems like it's more like a substitution type problem maybe, but really we have the natural log of 6x inside the squaring function. If you try just a normal substitution, if you let u be natural log of 6x with a normal substitution, there's no du to, outside of this to take care of us, right? The derivative of the natural log of 6x is not being, or multiple of that is not being multiplied by this. So, and you normally see integration by parts, it's a product of two or more things. So, where's the product of two things? Well, it turns out we can think of one of the functions as basically being the function 1, f of x equal 1. So the dv in this case is just going to be 1 dx. Our u, right? Remember how we choose u? It's Liate, and the first letter L means log function, means a function involving a logarithm. So we're going to choose u to be this whole thing in this case. This would not be something we would normally do with a substitution method, but it's certainly something we would do with integration by parts. Now we do have to, of course, here integrating is easy, right? The antiderivative of 1 is just x, so we get v is equal to x. This is a little more tricky because we've got to use a chain rule, right? When we take the derivative. The chain rule says take the derivative of the outer function, which is u squared, evaluate at the inner times the derivative of the inner. So the derivative of the outer, derivative of u squared is 2u, where u is the natural log of 6x, times the derivative of natural log of 6x. Well, when we take the derivative of that, another chain rule, right? U is equal to 6x. Outer function is natural log of u. So the derivative of the outer function is 1 over u, where u is 6x, times the derivative of the inner function 6x, which is 6. So we've got a chain rule within a chain rule. Of course, 1 over 6x times 6 just simplifies down to 1 over x, right? So I've got 2 divided by x, natural log of 6x. So du is equal to this, okay? Now, we're ready to use the integration by parts formula. Integral u dv is uv minus integral v du. So u we found, or we stated was this, v we found was this, so x times that gives me the uv, and then the integral v du, v is x, and the du is right here. Okay. So I'm going to clean this up. Notice what happens here when I have x times 2 over x. The x's cancel, and I just have a 2. I'll pull that 2 out, and I'm left with the natural log of 6x. Well, again, what's the antiderivative of this? Be careful. It's not 1 over 6x times 6 or something like that. That's, you're thinking of the derivative, right? We did that up here, right? The derivative of the natural log of 6x is this part right here. No, we want to integrate, and so we're going to have to use integration by parts again. And very similar, this time we'll let u be the natural log of 6x and dv be dx, so v is equal to x. And here the derivative is a little bit easier because it's just chain rule once. Derivative of the outer function, natural log of u, so 1 over 6x, times the derivative of the inner function, derivative of 6x is 6. We just get 1 over x, though. That's what that simplifies down to. So here is what I have, and so just recopying this quantity minus 2, and then in parentheses, we'll put in the integration by parts again. uv, x times the natural log of 6x, minus integral v du. And look what happens when I multiply v x times du, 1 over x. What's x times 1 over x? That's just 1, right? I get the integral of 1, right, dx. And what's the antiderivative of 1? It's just x. So this integral now we can do, and it's very easy to do. So let's clean this up a little bit. I'm going to distribute this negative 2, be careful, it's a negative 2, through both of these. And so I get negative 2x, natural log of 6x, and then be careful, negative times a negative is a positive 2 times that x. So here is the answer here in the box. That's fine for me. I think the answer they gave and achieved, they factored out the x. See an x common to each of these terms and wrote it that way. But again, either one should be fine for me. Okay, hope this was helpful.